All right, today we're going to talk about how to connect the different ways we've been interpreting limits so that when we know one way, we can understand it different ways, right? We're connecting the representations of limits. That's AP Calculus AB section 1.9. So with the limit as x approaches 2 of x squared, this example I have right here, we can easily use direct substitution. And if we use direct substitution, we get 2 squared, and that equals 4. And that's great. Plugging and chugging direct substitution, it is a great way to solve limits. And this is fine and good. However, we need to make sure we know what's actually happened when we say we're solving this limit. As x approaches 2, where is x squared going? Do we understand what that means in different ways? So for example, could we write it out in English? As x gets very close to 2 on the x-axis, the function, which in this case our function is x squared, gets really close to 4. That is how we interpret direct substitution and solving a limit analytically into a more verbal English way. We also need to be able to work on this graphically. So we need to be able to look at a graph of x squared and also be able to interpret what's happening on the graph the same way that we're able to do it analytically or speak about it verbally. So we can draw the parabola y equals x squared right here. And then as x gets closer, and we'll call this 2, as x gets closer and closer to 2 on the x-axis, what we're saying is that where is y going, or f of x going on the y-axis? And we can see it's getting closer and closer and closer and closer to this value, and this value on the y-axis is going to be 4. So that's how we do it verbally, graphically, analytically with direct substitution. And the last way we need to be able to connect the same limit problem is using a table. So what we're saying is that in the x direction, we can plug in values that give out outputs that get closer and closer to the value that we're looking for. That's what we mean by using a table. So we've plotted this table right here that gives, when we plug in a certain x value, what's happening to our function f of x equals x squared. And recall that we're just trying to show us plug points that get closer and closer to 2. So on the left-hand side, I have 1.9, 1.99, 1.999. They're getting closer and closer to 2 from the smaller side. And from here, we have 2.1, 2.01, 2.001. It's decreasing and getting closer to 2 from the larger side. So we want to look at the function values and see how that's being impacted to kind of give a feeling of what the limit might be, estimating what the limit is. And we can see that as we go and increase our value closer and closer to 2, we go 3.61, 3.9601, 3.996001. What this means is it's getting closer and closer to the value we're expecting for. And if you do it from the other side, 2.1, 2.01, 2.001, we are also getting closer and closer to 4. So what we estimate using a table is essentially just looking at the graph and plugging in points that get closer and closer to 2 to see what might be happening as we get to 2. And that's how you connect the same limit in different interpretations to just get a better understanding of what a limit is doing.